Hi everyone, my name is Mouna Abidi, and today I will be presenting our paper, Are Multilanguage Design Smells Fault-Prone, an Empirical Study. So first, let's start by defining what are multilanguage systems. So basically, multilanguage systems are systems that are developed with a combination of programming languages. Several applications with which we interact daily, including Instagram, Facebook, Google Chrome, YouTube, and Netflix, are all developed with a combination of programming languages. Those systems introduce several benefits that explain their popularity, including the lower development cost. Developers can leverage the strength of each programming language, they can save development time, they can choose the programming language proper for their need, they can reuse existing code and existing libraries. However, those systems also introduce new and additional challenges. They are more complex, they introduce dependency issues, the maintenance cost of this system is higher, they introduce security issues, they are more complex to understand, and they introduce new and additional bugs. With the aim of improving the quality of multilanguage systems, we previously documented a total of 15 types of multilanguage design smells, and for that we mined the literature, developers documentation, and bug report. We extracted a set of practices related to multilanguage systems. Those practices went through a validation process, and finally we documented the 15 types of multilanguage design smells. In this study, our objectives are at the first level to investigate if the documented multilanguage design smells are prevalent in open source projects. We also aim to investigate if some specific types are more prevalent than others, and we aim to study the fault proneness of multilanguage design smells and if some specific types are more fault prone than others. And finally, we aim to extract the risky activities that could lead to bugs once performed in smelly files. To achieve our objectives, we have defined a total of 5 research questions. Each of these research questions is addressing one of the defined objectives. So the first one is addressing the occurrence of multilanguage design smells. The second one is investigating if some specific types are more fault-prone than others. And the third research question, we are investigating if design smells are more fault-prone than files without smells. And the fourth research question, we are investigating if some specific types are more fault-prone than others, while in the research question 5, we are investigating the activities that could lead to bugs once performed in smelly files. To address our objectives and answer our research questions, we have collected a total of 98 releases of 9 systems. We have cloned this project and we performed 2 investigations. In the first investigation, we collected the information from the Git log and we identified the bug fixing commits. Then we applied PyDriller to extract the bug-inducing commits related to the bug-fixing commits. And we also proposed an approach named MLS Inspect. This approach detects occurrences of the 15 types of multilanguage design smells in the context of GNI systems. By GNI systems, we consider systems that are developed with Java and C, C++ programming languages. So we have applied the detection approach on the 98 releases of the 9 systems, and then we did the data mapping to map the information about the smelliness of the file with the information about the introduction of bugs. And then we analyzed the data to answer our research questions. So the approach takes a GNI project, so project with Java and C, C++. It applies SourceML to generate a unified SourceML representation for the whole project. Then, using a set of detection rules we are proposing for each specific type of design smell, we are using the XPath to navigate through the SourceML representation and apply our detection rules. And finally, we are providing 2 types of output. We have a summary output providing information for each file about the smells existing in the file, a source code file, and we are also providing detailed information for each specific type of smell, the location, the name of the method, class, parameter, and other information related to the design smells. The approach was evaluated on 6 GNI projects, and we have compute the recall and precision, and we report a minimum of 74% of recall and 88% of precision. So now let's consider the first research question. So we are checking if multilanguage design smells are frequently occurring in open source project. And as we can see in this table, we can observe that multilanguage design smells are frequently occurring, and they occur with an average value of 34% in all the studied systems. We also investigated if multilanguage design smells persist in the studied releases, and we have observed that occurrences of multilanguage design smells persist and even increase from one release to another. Regarding the second research question, where we are investigating if some specific types are more frequently occurring than others, as we can see in this table, we can observe that a used parameter is among the most frequently occurring design smells, followed by not secure in library, too much scattering, excessive interlanguage communication, and unused method declaration. Those are among the most frequently occurring design smells, while the less frequently occurring are excessive object and not caching objects. We also investigated the evolution of each specific type of multilanguage design smells, and we have observed as overall that in general multilingual design smells persist and increase from one release to the other. Now, regarding the fault proneness of multilingual design smells, we have applied Fisher exact test, and we report our result from applying Fisher exact test. And as we can see here, we have ODS ratio more than 1 with significant p-value, which indicates that files with multilingual design smells often lead to bugs more than files without these smells. Now, regarding the fault proneness of each specific type of smell, we have applied logistic regression models, and we can observe that the most fault-prone design smells are in used parameter, too much clustering, too much scattering, hard coding library, and memory management mismatch, as we can see in this table. Now, regarding the activities that are more likely to introduce bugs once occurring in smelly files, we have investigated the commit messages related to the bug-inducing commits. We have applied topic modeling, and we did manual labeling and manual verification, and we have reported as risky activities the activities related to data conversion, memory management, exception management, restructuring the code, and API usage. Those were reported among the most risky activities that could lead to bugs once performed in smelly files. Now, regarding the implication from the studies, we have proposed an approach named MLS Inspect. This approach allows the automatic detection of the catalog we are proposing of multilingual design smells. We have also reported that multilingual design smells are prevalent and that they persist and even increase in the releases. We also reported that files with multilingual design smells could often lead to bugs more than files without design smells, and that the frequency and impact varies from one specific type to another. And we have also pointed that the unused parameter, too much clustering, too much scattering, hard coding library, and memory management mismatch are among the most fault-prone design smells. And we also pointed the activities that could lead to bugs once performed in smelly files, and we believe that further research is necessary to have additional insight into the impact of multilingual design smells. Now, to conclude, in this presentation, we have reported our objectives in the study, and we have reported that multilingual design smells are prevalent and that they increase from one release to another. We also reported that multilingual design smells are often related to bugs and that the impact varies from one design smell to another, while we have pointed the most fault-prone design smells. And finally, we have performed a qualitative analysis and extracted the activities that could lead to bugs once performed in smelly files. Thank you.
All right, we are live. So thank you everybody to joining our session on patterns smell. I thank Mouna Abidi from the Polytechnique Montreal in Canada for her presentation. on our multi-language design smells fault prone and empirical study. So I encourage all the audience to write their questions on the chat. And meanwhile, we can start with my question. So my first question is, how do you define a multi-language design smell? So we already have a lot of smells that are related to a monolanguage somehow program. So what are these multi-language smells? Are they the same smell but applied to multiple language? Is it the same file? These are two different files. So one file is one language, another file is another language. So how does it work, this multi-language design smell?
Thank you for the question. Actually, the design smells defined for monolanguage are applied for a specific programming language. Here, what we consider as multilanguage systems, it's actually new design smells that we previously defined and documented. They are available in another paper we are citing, published in Pattern Conference. It's Europrop conferences. And actually, the big goal here with defining new type of design smells dedicated to multilingual systems is that we want to consider the interaction between programming languages. So, for example, we can have, for example, a method that is used in the Java, and there is another, it could be, for example, defined in the Java side and implemented in the C, C++, or like the native side. And that interaction could not be performed in a good way that could result on a smell. So all the smells defined, even if some of them could be applied to, let's say, one specific programming language, but the main goal here is to consider the interaction of programming languages. So they are. This is the big difference between mono and multi, but it's a new type of design smells.
Nice. Thank you for your question. It was very clear. My next question is, while I wait the audience to pose their own questions, my next question is, what do you think would be the next steps to make it actionable in industry? I mean, if you bring your paper to an industry, okay, to a company, how can they make in practice the findings that you proposed in the paper?
Okay, so when defining the design smells, we analyzed the code of open source project, and some of the projects were used by company, even if they are open source project. And even in this paper we are presenting here, when analyzing the prevalence and also the impacts, we also analyze projects that are related to, like, for example, Conscript, it's a Google product, RocksDB, it's a Facebook product. So those are open source systems, but they are also kind of used in the industry. But the way we define the smell is, maybe we need to do reproduce the study with like project from the industry, but the way the smells are defined, like those smells could exist even in industry project. But to confirm this, we may need to conduct further study and also to deeply investigate the industry projects. But those. So if we bring this to the industry, the main point is that we have, from analyzing the prevalence of the smells, we have reported that design smells are prevalent in the project, and that, well, some specific types are more prevalent than others. And we have also reported that they have impacts on the bug. So this is also important to, if we have that impact on bugs, and if we can give those information to the industry, maybe they can they can use our result to mitigate the introduction of bugs. And also we have introduced the activities that once performed in smelly files could lead to bugs. So even the approach, everything, I think, could be used in the industry to improve the quality of multilanguage systems. So those are the main thing. And another point is that we have captured in the commit message, we have reported that in some cases, developers were refactoring and removing occurrences of the smells. So this is also adding information about the importance of removing and addressing the design smells we are reporting.
Nice, thank you, Juan. Another question I have is, if you need to speculate, okay, so you probably don't know the answer, but if you need to guess, in which context your results will not apply? So you provided some results, okay, that are related to a specific set of projects, a specific set of mails, and we have seen that those mails have some characteristic, they are defect prone and blah, 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 okay? Now, if you had to guess, where do you think those findings would not apply, if any?
Yes, actually, we may need, what we did is that we analyzed a subset of systems. So even the results we are reporting are not generalized for all the systems. So it's a subset of systems. And also another point, maybe if using another combination of programming languages, maybe we cannot have the same results, because the design smells we defined are not only for GNI project, it's multilanguage design smells. So we are expecting those to be prevalent not only in Java and C++, but also in other combination. But the application, the approach we are proposing is only detected in the context of GNI, so Java and C++ programming languages, and all the results we are reporting about the prevalence and impacts are related to the GNI systems. So maybe if we consider Python, C, or another combination, maybe we not really find them as prevalent as they are in the GNI, or maybe even the impact will not be the same. But all those we need further investigation to be validated.
Nice, thank you. So my final question, since there are still 2 minutes, is what is next? Yes.
Yes, so this is a new topic. It's a new research area, so there is a lot of things to do. And we are actually still investigating the impact. We are considering the time to bug. We are considering the survival. So we are considering a lot of things. But one big point I will say for this as what is next and future work is to reproduce this study with another combination of programming languages, and also to adapt the detection approach to detect the smells in another sets of programming languages. But this is a new topic, because if we see this for monolanguage systems, we have already a lot of studies that investigated the existence, the impacts, and so on. But for multilanguage systems, this is not really, it's not common yet. So I think this is providing a lot of opportunities to investigate, document practices, and also investigate the impact and and prevalence. So yeah, there is a lot of things to do, not only one. It's a new research area.
So, yeah, so there is still 1 minute remaining. I don't see any other question. So I take this time to thank again Mouna for her presentation and for her ability to answer my questions. And if you are interested to talk with Mouna, of course, there will be a pop-up button that you can click, and this will bring you to a discussion room where you are free to talk with her about future research directions on these new kind of smells. So again, thank you very much, Mouna. Thank you very much, everybody, and see you in the question and answer for the next paper. Thank you, everybody, and bye-bye.
Perfect. Thank you so much.